Alright, so biotransformation of parathion. Now, parathion is a phosphate pesticide. This one is a little common. It's used in killing mosquitoes, weevils, and other insects. Now, this is the structure of parathion. If you look at this, what we have in here, 2 carbon attached to, just if you are drawing this, the simplest way to draw this is to start with your phosphate. But your phosphate now is attached to sulfur. Then on this side, attach an ethyl group. On this side, the same thing. So you attach this CH3, CH2. Same thing here, CH3, CH2. Then here you attach your benzene ring attached to a nitro group. So this is the structure of the parathion. Now, this parathion can undergo desulfuration, removal of sulfur. So if sulfur is removed, we will have something like this. What's the name of this structure on the board? This is what? Parathion, right? Now this parathion can undergo desulfuration, removal of this sulfur group, and what we have there is O. So it's now changing from parathion to para-oxone. From parathion to para-oxone. And this para-oxone is very toxic. Sorry? The oxygen after where? Alright, thank you. So this para-oxone is very toxic. So it needs to be further metabolized in the body. So this can further be metabolized. The enzyme that will catalyze this reaction, desulfurase, will catalyze the removal of sulfur group from parathion to form para-oxone. So if you know the structure of parathion, just remove the sulfur and put oxygen and you get para-oxone. But this para-oxone is very toxic. So another enzyme will come in to break down this para-oxone. And this para-oxone now will be broken down. If it is broken down, now look at this, just look up, stop writing. An enzyme called phosphodiesterase will come in and break this bond at this point. Look up. Phosphodiesterase will come in, break this bond. So we'll be having 2 compounds now. So phosphodiesterase will break this bond. If we split this bond, what are we going to have? CH3, CH2, O. This bond has been broken, right? So what are we going to have here? But remember, this is still attached to this, right? Okay, let me take this away first. So what will happen at this point? What is happening here? OH, right? If water is used to split this bond, OH will be attached here. Plus, now if this side is going up, what is remaining? Just this side, right? So we'll be having what will now be here? OH, right? Now let me take that again. Phosphodiesterase is the enzyme that will split this bond, because para-oxone that is formed is very toxic. I'll give you the notes. It's very toxic. Now if it splits this bond, we are having the O of this detached from this. So this now, this, if it's removed in the presence of water, remember water is HOH, right? Meaning this reaction, is it hydration reaction or hydrolysis? hydrolysis, right? Because you are using water to split a bond. And you know, if you are using water to split the bond, water will be added across, right? So if you split this bond, I just made this straight. Then OH there will be attached here. Then this one remaining was supposed to be only oxygen here, right? But we have hydrogen left. Add it to this one. So you have two new compounds. What will you call this? If you check this, what is here is the same thing as what is here. So what will you call it? Di what? Diethylene phosphate. That's all. And what will you call this? What will you call this? 1, 2, 3, 4. 4 nitro what? 4 nitro what? Phenol, or is a para-nitrophenol. Para-nitrophenol or 4-nitrophenol. So that's the metabolism of parathion. You saw it in the past station there. So first, it undergoes desulfuration, removal of sulfur group to form para-oxone. From para-oxone now, since this is more toxic than the parent compound, it is broken down into two new compounds, diethyl phosphate and 4-nitrophenol. Help me this.